Hey kids, this is a new topic, and I'm also recording without the headset, as you can see, because somebody said I need to get away from that and focus on getting a good Bluetooth uh, mic and so on, which I have got. I tested the sound, it seems to be okay, so let me see how it goes with this recording. So I'm going to talk for 10 minutes and then find out if it worked as well as it did in the test. So hopefully I don't have to re-record it and again to complain about the bloody interface that Microsoft has given me where Windows just resize by themselves trying to copy the Mac style and a complete disaster. I hope Microsoft will fix the bloody thing. What is it? What is this topic? We are still talking about the evolutionary traits and what they actually mean in terms of our ability to change, to meet the needs of climate action, adaptation, and mitigation. Many issues already. We talked about two topics: how our evolutionary trait has basically brought us to the Anthropocene, the modern climate change, and how these positive feedbacks that we create with the environment and create these human constructs, niche constructs, and we can call them in many ways. But this is a nice topic which talks about a modeling of evolutionary group selection approach to look at how decreasing global inequality will affect local cooperation and what it could mean for sustainability, obviously, or climate action. So it says reducing global inequality increases local cooperation, a simple model of group selection with a global externality. If you are anywhere near understanding evolution, which you don't have to, there is individual selection, genetic selections, fitness of the gene, what is evolutionarily stable and what's not stable, and so on. And then there are ideas of how group selections happen, which is, along the ways of our gene cultural evolution. So here, the externality is the changing global inequality, and you want to look at local impacts in terms of cooperation. Lots of equations, lots of simulations. I will skip all the details of the model and just read some key points because this topic is very important. And evolution models are, no worse than our climate models in terms of uh, providing a guidance. We have good weather predictions, climate predictions, and then we get into climate projections, which go off into la la land with lots of assumptions and scenarios, and the projections out to 2100 are basically dominated by uncertainties in scenarios and so on. So I like evolution models as well as just as fine as the weather and climate models. Group structured models often explain the evolution of pro-social activities in terms of selection acting at both individual and group levels. Such models do not typically consider how individuals' behaviors may have consequences beyond the boundaries of their groups. However, many behaviors affect global environmental variables, including climate change and ecosystem fragility. That's the context in which we are doing this whole podcast series. Against this background, we propose a simple model of multi-level selection in the presence of global externalities. In our model, group members can cooperate in a social dilemma with potential for group level benefits. Typically that means you're paying a cost at an individual level. Okay, the actions of cooperators also have global consequences, which can be positive, which will be a global good, or negative, which will be obviously a global bad. We use simulations to consider scenarios in which the effects of global externality either are evenly distributed or have stronger influences on either the rich or the poor, broad classification for this modeling sake. We find that the global externality promotes the evolution of cooperation only if it either disproportionately benefits the poor or disproportionately reduces the payoffs of the rich. If the global externality primarily harms the poor, it undermines the evolution of pro-social behavior. Understanding this effect is important given concerns that poorer households are more vulnerable to climate change impacts. This article is part of the same issue that we've been looking at, evolution and sustainability, gathering the strands for an Anthropocene synthesis. So, poor are suffering, they are more vulnerable. The accumulated carbon and climate change is basically being caused by the rich. So this is important in understanding why poor may or may not cooperate in climate actions and sustainability unless they see a clear payoff that benefits them, or the payoffs to the rich that is reduced while they are doing cooperation, right? So introduction wise, the global externality can be either positive, a global good, or negative, a global bad. In the first case, cooperators generate global benefits that increase payoffs of everyone in the population. In the second case, a global bad reduces everyone's payoffs. So it's like prisoner's dilemma versus Nash equilibrium. We study, well, Nash equilibrium is a bit more complicated, so let's not worry about it at this stage. We study evolutionary dynamics of our model under three distributions of the global externality: uniform, proportional to payoffs, and inversely proportional to payoffs. We will show that the externality promotes the evolution of cooperation when the global good disproportionately benefits the poor, or when the global bad falls mostly on the rich. Okay, so without reading all the details of the model and the other literature and so on, we are just saying that this model is trying to capture certain aspects of group selection and looking at the impact of global externality, which means, inequality across groups doesn't necessarily play into group selection, but you have defectors, you have free riders, you have people who stay in the group and so on, which all affect group selection. Moreover, we show that the size of the global externality is less important than its distribution for the evolution of cooperation. The more the distribution is skewed in favor of the rich or the poor, the greater the impact of the greater the impact the global externality has on pro-social behavior. So we are basically trying to see what can work in the context of these intra-group interactions that drive either defections or cooperation. And then you want to worry about an externality that is coming in that is affecting your group in terms of uh, affecting the poor and imposing the global bad on the group members and so on and so forth. Okay, so evolution of cooperation by multi-level selection is the approach to the model. Group selection provides a powerful conceptual framework to study the evolutionary mechanisms acting on different levels of organization. In particular, cultural group selection theory has been helpful in explaining diffusion of pro-social behavior, the evolution of different types of institutions, and the emergence and persistence of sustainable social ecological states. Cultural group selection, as compared with group selection operating solely on genes, involves cognitive learning and cultural acquiring of social traits. So it's critical to at least get a sense of what we mean by cultural group selection versus group selection operating solely on genes. So if you have a community that is related or somehow selected genetically to cooperate, that is different than cultural group selection, where now you can imagine that you're sitting in one place, but you are connecting via the internet or so, some other media across the globe with cultural affinities that is way beyond genetic selection. So we have gene cultural evolution, as we already said, and that has some handicaps in terms of how we cooperate within groups and how we compete across groups to maximize our payoff, and how sustainability can be, deleteriously affected by these intergroup competitions, because then you're not necessarily going towards the Nash equilibrium where you are optimizing your payoff and not maximizing it by considering constraints and requirements of the other groups as well. Okay, we discussed this in the previous podcast. So just get an intuitive sense that we're talking about cultural group selection and how a global externality can affect this. Just in terms of what the model does, to examine the impact of the global externality on cooperation, we consider 7 scenarios and then results are given. The graphs are complicated to interpret in terms of all these parameters. So I'm going to skip showing any of the graphs, but we'll read the conclusion to get the main points of the study and understand why it is relevant for us. The baseline scenario in which we assume no global externality. Scenario one, an equal distribution of the global good with the global good distributed equally within the population, so no rich poor thing. Second scenario, the global good favors the rich. Third scenario, global good favoring the poor. Fourth scenario, an equal distribution of the global bad with a global bad that is evenly distributed within the population. So your cooperation is not working in a way that it is creating a global good. Let's say everybody is maximizing their payoff, so you are resulting in good payoff, but you're creating a global bad. Scenario five, the global bad disfavoring the rich with a global bad that is disproportionately reducing the payoffs of the rich. And finally, the global bad disfavoring the poor with a global bad that is disproportionately reducing the payoffs of the poor. So, how the rich benefit, how the poor benefit, you expect you expect that that will affect the poor. Why should they do anything if they don't see a payoff, an incentive? This is very important to understand in terms of how cultural evolution, diffusion of the memes across groups work in global externalities. So, conclusions. Our results show that if local behaviors have consequences beyond group boundaries, the evolution of cooperation in the population can be affected via the global impacts of those behaviors. We have used a simple model of multi-level selection to derive the general condition for the evolution of pro-social behavior in the presence of a global externality. They want local pro-social behavior cooperation despite the global externality that may be affecting you negatively. We showed that a global externality has no effect on within group or between group selection when it is evenly distributed among all members of the population, regardless of the magnitude of the externality. So, if you are not creating winners and losers, then the pro-social behavior is not affected positively or negatively. But global change, climate warming, climate change, global warming is now creating disproportionate impacts, which means the payoffs are not equally distributed across groups or within a group. This makes sense since a trait that affects every member of a population equally will have no effect on the relative fitness and thus cannot influence selection between individuals. However, if the global externality is distributed unequally in the population, it can have a large impact on pro-social behavior. Cooperators evolve within the global good disproportionately, sorry, Cooperators evolve when the global good disproportionately benefits the poor, or when the global bad falls disproportionately on the rich. In other words, when the benefits of cooperation are bestowed preferentially on those most likely to themselves be pro-social and therefore relatively poorer than the more selfish individuals. Assumptions involved there, but let's not worry about it at this point. This effect is stronger the more skewed the distribution of the global externality is, right? The more the poor benefit, the more pro-social they get. The more the rich benefit, the less pro-social the poor get. So if you assume the rich are more selfish individuals and are maximizing their payoffs, then already the group selection model has that built in. Okay, so is it surprising? Intuitively, not so, but modeling and finding this that global inequality can be a externality that can affect pro-social behavior and local cooperation will allow you to use that lever to drive climate action from bottom up, right? One of the most important implications of our model is that when the global bad disproportionately affects the poor, the evolution of cooperation is undermined. In general, cooperators are relatively poorer than other group members because they bear the cost of financing the public good that benefits everyone. However, groups with many cooperators are better off, i.e., everyone in such groups receives a higher payoff compared with groups dominated by defectors. Okay, free riders, defectors, cooperation always comes with free riders because if many group members are cooperating to create a common good, there will be free riders who benefit without contributing. If climate damage is disproportionately, if climate damage disproportionately reduces cooperators' payoffs, this prevents group selection from promoting groups with many cooperators. In this context, our results provide another argument for increasing efforts to mitigate climate change, which will benefit everybody, hopefully, even though we don't know always if reducing CO2 across the globe will have, beneficial climate change effects on everybody. It has been shown that when climate change primarily affects the poor, greater mitigation efforts are needed than when damages are proportional to income. Our analysis reveals that under an unequal distribution of climate change not only reduces payoffs, but also undermines pro-social behavior. Reducing the inequality that results from the unequal effects of climate change, uh, for example, through subsidies, could reduce the negative effects of this type of inequality on cooperation. So essentially, ideas like loss and damage, helping people adapt, capacity building, information, technology transfer, intellectual property transfer, etc., are all about reducing this global externality of inequality. Our results have been shown to depend on the distribution of initial wealth. So it depends on how you started. We can interpret payoffs differences imposed exogenously on individuals as those caused by historical contingencies in economic development or by differences in natural resources between groups. So even if you started with equal distribution of wealth, uh, resources may still be unequally distributed, so how you grow depends on all those sorts of things. There are many other impacts, many other traits that are involved. When factors other than payoffs in social dilemmas determine individual wealth, overall cooperation may be reduced. This has also been found by other researchers. Bruton and Borgerhoff Mulder, for example, showed that if the wealthy benefit more from cooperation than the poor, initial exogenous differences in wealth can promote cooperation via coercion. This happens a lot when landowners coerce farmers who are tending the land and so on. Although in our study, wealth inequality undermines cooperation, it does not entirely eliminate the effect of global externalities. This is especially true under strong selection, where they can tweak the parameters to say make strong selection based on this trait or this externality or weak selection, then initial wealth is distributed among population members from a distribution with a low mean. Anyway, details. This latter assumption may imply fairly low levels of global wealth or natural resources. This in turn suggests that global externality is particularly important in the early stages of economic development, or that it may become more important in the future with progressing resource scarcity at global level. So many ideas, but just remember that local cooperation and local pro-social behavior among the poor depends on how they perceive global externalities like inequality, uneven climate change impacts, and payoffs for cooperation, and so on. Okay, so let's leave this here. It's a nice topic. I'm very happy to cover these things. You can read the paper, very nice explanation of the model, many details, many good uh, references from previous related work, and so on and so forth. See you in the next topic in this stream of evolutionary traits and climate action. Okay.